Welcome back, Physical Science 20. Hopefully you had time to work through questions 2 and 3. And we'll look at the results here. So the first one, we're starting off at 3.25 moles and going to formula units because silver is a metal, nitrate are non-metals, so that's formula units. And then number 3, calculate the number of molecules in 11.5 moles of H2O. So of course, H is considered a non-metal when it's bonded like this. So that is in fact a molecule. Okay, so looking over here, so we're going from 3.25 moles to formula units. So moles is my old unit on the bottom, formula units is my new unit on top. So of course that's going to be this conversion factor again here. Moles on the bottom, formula units on top. So we have 3.25 moles multiplied by formula units over in moles. Moles cancels. My unit that I have left over will be this. So using that, 3 sig figs, 1.96 times 10 to the 24 formula units of silver nitrate. So I just use an F and a U for formula units there, and you can get away with that too. And I won't even get mad. Okay, the next question, number 3. 11.5 moles of water going into molecules. So moles is before, molecules is after, moles is before, molecules is after, so it's the same conversion again. So multiplying by 6.02 times 10 to the 23rd over 1 mole, we should have got 6.92 times 10 to the 24 molecules. So if you're not getting those answers, please be sure to call me and we'll take a look at what went wrong. Okay? Now I'm not sure how much room you actually have on your booklet, so you may be doing this on loose leaf, which is fine. We're going to look at question number 4 now, which is over here. I'm going to have to make this a little bit smaller so we can see it. So question 4, how many moles are in each of the following? So 5.75 times 10 to the 24 atoms of aluminum. So aluminum is just a single element, so it's called an atom. This many molecules of CO2. This many formula units of zinc chloride. And zinc chloride is a metal and a non-metal, so it's a formula unit. And lastly, atoms of iron. Okay, so we're going to be looking at that. So the first one, we're going from atoms of aluminum to moles of aluminum. So atoms is the old unit, moles is the new unit, so moles should be on top, and the particle of atoms should be on the bottom. So this time we're doing it like this. And now it's crucial that you use this scheme to represent that number because you'll run into issues if you just simply type times 10 to the 23, etc. Okay, so here's how we set it up. 5.75 times 10 to the 24 atoms multiplied by 1 mole over 6.02 times 10 to the 23 atoms. So your units should always cancel here and left with the unit on top that you're looking for. So make sure you run through that. 9.55 moles of aluminum. 3 sig figs, 3 sig figs. Okay? B, C, and D are very similar. So if we look back over here, we have the questions there. I'll maybe get you to write them out here. So here's B, C, D, and I want you to try it. So once you're finished writing these, pause the video, try them out, and then come back and see how you made out. So go ahead and pause the video now. Okay, if you had a chance to do that, here are the answers. So the part B, going from molecules to moles, molecules to moles. So it's the same factor, it's just the unit is different here, depending upon the substance that we're working with. Okay. Part C, going from formula units of zinc chloride to moles of zinc chloride. So again, moles is on top, formula units on the bottom to cancel out. And we get that, 0.595 moles of zinc chloride. And lastly, 2.5 moles times 10 to the 20 atoms of iron going to moles of iron. So atoms on the bottom, moles on top. atoms on the bottom, moles on top, cancel, cancel, and we're left with decimal 0.000415 moles for 3 sig figs, or I chose to write that in scientific notation, which is fine too. Okay, so simple conversions from moles to particles, whatever those particles represent, and vice versa. Okay, here's a few other ones. These ones here, so I have all the questions on this sheet, so see if you can work through these. Maybe pause the video at this point, run through these, and then come back on the video and see how you made out. Okay, so go ahead and pause it now. Okay, if you had a chance to do those, here is the solution, going from moles of silver to the represented particle. Now, in this case, it's just silver by itself, and so that is an atom. So moles and moles cancel, we're left with atoms. 3 sig figs, 1.51 times 10 to the 23 atoms. Sodium chloride. Sodium chloride, of course, is a formula unit. It's not an atom, because it's two things. It's not a molecule, because sodium is a metal. So a metal and a non-metal, the unit we use for that is formula units again. So moles going to formula units. So again, but if you set it up like this, you'll be able to easily see what the unit was before, what the unit is after, what the unit is before, what the unit is after. So we have 5.15 times 10 to the 21 formula units of NaCl. Carbon dioxide, going from moles to the representative for carbon dioxide. Carbon and oxygen are both nonmetals, so we're talking about molecules. So the numbers are arranged the same here, it's just that the particle unit is slightly different. And the answer there works out to be 2.13 times 10 to the 25 molecules. Okay, the next questions involve doing vice versa. So going from particles, which could be atoms, molecules, or formula units, back into moles. Okay, so go ahead, pause the video, and work through those and see what you get. Okay, if you had time to do that, we're going from atoms of lead to moles. Old unit is atoms, new unit is moles. So there you see, old unit of atoms, new unit of moles. 5.4 times 10 to the minus 4 moles of lead. Okay. Looking at the next one here, we have a few more examples. Going from molecules of glucose to moles. So molecules to moles, unit on bottom, unit on top. So you can see that unit on bottom, unit on top, and it works out quite nicely. 8.24 times 10 to the 4, or sorry, just simply 8.24 moles. Going from formula units of sodium hydroxide to moles. So formula units to moles, bottom unit, top unit, bottom unit, top unit. So you can see where you're starting from, where you're going to. That helps you set up that conversion factor. So 0.259 moles of NaOH. And that's it for calculating. We'll look at some vocab here. So moles is the base unit of a substance. Sorry, the base unit used to measure the amount of substance. And actually, the funny thing is here, there's a short version for MOLE, and it's just MOL. So if you see MOL, that's not a mistake. It's actually the short version for mole, because who in the heck wants to write that extra E? So 1 mole equals 6.02 times 10 to the 23rd things or particles, and as we've seen, of course, those particles could be atoms, molecules, or formula units. And of course, Avogadro's number represents how big a mole is in terms of how many atoms, molecules, formula units, or things. 6.02 times 10 to the 23rd. Okay? Now, the last thing I'm going to leave you with is this chart here. This is going to be very important and very handy for you to get down. So it represents all the conversions we're going to look at I kind of call it the Y chart because it's in the shape of a Y. So far with this booklet, we looked at this region, going from moles to particles and particles to moles. And you can see the conversion factors go with the particular arrows. So you have, this is what we had practice with, so in the next booklets we'll be looking at converting between moles and mass, and also between moles and volume. So give you a chance to copy this out. So maybe pause the video, get this copied out in this section, and we'll be able to go from there. STP here just simply means standard temperature and pressure. So when that happens, 1 mole is 22.4 liters or vice versa. Okay? So copy this out, and then we'll see you next time.